Okay, let's go to page 337 and let's do the word problem. Let's do number 1. It's according to Ohm's law, so this has to do with physics. Okay, according to Ohm's law, the current flowing through the wire, so current is I, flowing through the wire is inversely proportional, means K over proportional to the resistance of the wire. Okay, so that's the translation. It says if the current is 5 amps, okay, so A is the amps, when the resistance equal to 24. Now the horseshoe symbol, that is the label for the resistance. This is ohms. Okay, for what resistance would be 6 amps. Okay, so again, just like before, so go and substitute to find the K. So 5 equal to K over 24, cross multiply, so K equal to 120. So update your equation, so I equal to 120 over R. So now to find R, you substitute, so you got 6 equal to 120 over R, cross multiply, 6R equal to 120, divide by 6, so R equal to 20, and the label would be ohms, the upside down horseshoe. Okay, and that's it. Okay, let's go to number 2. Okay, it says electromagnetic transmission, the frequency, so frequency vary inversely, right? So frequency vary inversely as the wavelength. Okay, so let's call it L for wavelength. Okay, and it says a signal frequency of 750 kilohertz, which might be the a signal of frequency 750 kilohertz, which might be the frequency of the AM radio station, has wavelength of 400 meters. Okay, so it says what frequency has a signal wavelength of 600 meters. Okay. So again, just like before, substitute to look for K. So 750, and we can just drop the label for now. Okay, just focus on the number, equal to K over 400. Right? So K equal to, okay, so that's going to multiply out. So K will equal to 750 times 400. So K will equal to 300,000. Okay, so update your equation. So F equal to 300,000 over L. So now we can use the updated equation to solve. So F, the frequency equal to 300,000 divided by 600. Okay, so substitute. Again, you can cancel. Okay, so F equal to 500 kilohertz. Okay. Okay, let's go to the next one. Okay, we skip number 3, so let's go to number 4. Okay, electrode resistance of a wire, so that's R, varies directly, okay, as its length. So resistance varies directly as a length and inversely as the square of the diameter. Okay, so that's your translation. Now it says 50 meters of wire, so that's length. Okay, 50 meters of wires with diameter of 2 millimeters has a resistance of 9 ohms. Okay. Find the resistance. Find the resistance of the 120 meters of wire of the same material if the diameter of this is the length. Length is 120 meters of the same material if the diameter is 3 millimeters. Okay, so same thing. Let's go ahead and substitute everything to look for K. So you got 9 equal to K times 50. Now you don't have to worry about labels since they're all the same there, so they will all work out. So this is 2, so I'm going to make it 2 squared, right? So cross multiply, you get 36 equal to K times 50. Okay, and then divide by 50, divide by 50. So K equal to, I guess this one is going to come out nice, so you can use decimal. So 36 divided by 50, okay, equal to 0.72. So once you find K, let's update the equation. So R equal to 0.72 L over D squared. Okay, now to find R, again, we substitute everything in here. So R equal to 0.72 times 120 over, now be careful, now the D squared, right? So it'd be 9, okay? Or 3 squared. Okay, that's going to just do that, 3 squared. Okay, then you work it out. So R equal to 0.72 times 120 divided by 9 equal 9.6 ohms. Okay. Okay, let's go to number 5. Okay, again, read through. So it's heat loss. So I'm going to call it L. So heat loss through a glass window vary jointly as the area of the window and the difference between the inside and outside temperature. Okay, so I'm going to call it delta T. Okay, the temperature difference. Now it say if the loss through 3 points, so area equal to 3.2 meters square. Window is, so the heat loss is 700 BTU per hour through the 3.2 meter square window when the temperature difference is 12 degrees. Okay. Okay, so it says what is the heat loss? What's the heat loss through a 4 point, so area equal to 4.4 meters square. Window, the temperature difference is 15 degrees. Okay, so just like before, okay, work it through. So first, let's substitute everything here. So 700 equal to K times 3.2, delta T is 12. Okay, so to find K, you divide by 3.2 and 12. So divide by 3.2 and 12. So all this will cancel out. So K equal to, okay, get your calculator, work it out. So 700 divided by 3.2 divided by 12. Now everything on down here you have to divide. Okay. Okay. So it didn't come out too nice, but that's okay.
Good morning, Honolulu Upper School. For today's SVF, juniors and seniors are in the gym first. Freshmen and sophomore go to homeroom. Thank you.
Okay, so once you find K, that's going to update the equation. So L equal to 18.229 A delta T. Okay, so substitute everything in here. So L equal to 18.229 times 4.4 times 15. So L equal to, and notice that in my calculator I have this number, right? So I can just use that. So that way I don't chop up too many digits. Okay, so just go and times it by 4.4 times 15 equal. So you're going to get 1203.125. Then after that you can run it off, or you can just leave it. BTU per hour. Okay, and that's it.